Hi, in this video, I'll be talking about graphs. Just kidding, not these graphs. The graphs in this video will be a little different because it's under the concept of network theory. In network theory, a graph is a set of nodes and edges that can represent information. Essentially, a graph is made up of two parts. See this circle? This is a node or a vertex. It represents any entity. See this line? This is called an edge. It represents a relationship between nodes. When you put these parts together, you get a graph. A graph can be denoted like this, where V is a set of all nodes while E is the set of all edges. A graph is said to be connected when all nodes are connected by an edge or a sequence of edges. A component is a disconnected part of a graph. A degree is the number of edges a node has. In this example, the node 5 has a degree of 3. There are many types of graphs. Here are some of them. This is a simple graph. It has no multiple edges or loops. A directed graph has edges with directions and loops. A weighted graph has weight associated to its edges, which can represent values such as distance. Edgeless graphs has, well, no edges. This is a null graph. As you can see, it has no nodes, no edges. A tree graph is where any two nodes have only one path between them. This graph is a regular graph because all nodes have the same degree. A complete graph is where all nodes are connected to all other nodes, each with a single edge. Graphs with edges that do not intersect are planar graphs. Subgraphs are graphs which are components of bigger graphs. With so many kinds of graphs in existence, some of you may be wondering, what are these used for? Well, graphs in network theory are heavily used in data science. The example on the left is a graph used to analyze friendships on Facebook, while on the right is a graph representing billions of devices connected to the internet. Another application of graphs in network theory is this weighted graph with numbers representing units of distance. Try to find the shortest round trip from A that passes through all the other nodes. The shortest path is from A, then B, then C, then D, then back to A. Or from A, then D, then C, then B, then back to A.